We're going up close and personal with triangles. These are the most important ones for the SAT and the ACT. They love right angle triangles because the SAT makers are clever and they almost want to show their cleverness by having nice, clean answers to things that otherwise look gnarly. This is something that looks gnarly. Remember this? A squared plus B squared equals the hypotenuse squared. It's the Pythagorean Theorem. It works with a lot of squaring and then subtracting. A guy named Pythagoras found some triplets a long time ago in Greek where the numbers come out cleanly. He knew that 3 squared plus 4 squared equals 5 squared on a triangle that actually works. That these could be lengths of a right angle triangle and there's no ugly numbers in between. It works. 9 plus 16 is indeed 25. He knew that 5 squared plus 12 squared were the base and height of another right angle triangle that have a hypotenuse of 13. 5 squared is 25. 12 squared, 144. And sure enough, a nice clean 13 squared became the hypotenuse. Here's the ones that the SAT especially loves. They like ones that correspond to this, their favorite triangle, the 30, 60, 90. This triangle has proportions of 1 to root 3 to 2. Look how that plays into Pythagoras' theorem. A squared plus B squared equals C squared. Oh, and it really does. 2 squared is 4. Root 3 squared is 3. 1 squared is 1. The equations really equal. This proportion, 1 to root 3 to 2, needs to be memorized. For ACT and SAT success quickly, you need to lock this in. Now, the SAT makers know that most students have locked this in, so they'll take it to a higher level. They'll use the same numbers, but in a higher proportion. Instead of root 3, maybe they'll use 8 root 3. Maybe they'll tell you that you're looking at a 30, 60, 90 triangle with one side opposite the 60 of 8 root 3. They'll ask you for the other sides. Here's how you go about it. You know the proportion is root 3 to 1. If this is 8 root 3, this lower side is now 8. You also know the proportion of smallest side to hypotenuse is 1 to 2. You know this is 8. It makes the hypotenuse 16. You don't have to do the Pythagorean theorem if you know these proportions. Look at how this beautiful triangle comes into play on another type of triangle, the equilateral. This is a 30, 60, 90. Well, there's another 30, 60, 90 that if attached side by side makes a 60, 60, 90. With two 30s up there, there's 60 degrees. There's another 60 degrees. Here's the final 60 degrees. Now, an SAT might rely on you knowing that the height is root 3 times half of this base. So if they told you, you are looking at an equilateral triangle with sides of 16 each, you can find the height by simply saying, well, that would mean an 8 and an 8 are the two sides here. And 8 root 3, which you didn't have before, now is inputtable there. I'll make it prettier. 8 root 3. From here, you can get the area. From area, you could go back and get perimeters. Know your 30, 60, 90 triangles, and once again, double the smallest side, and you have the length of the hypotenuse, the longest side. Take root 3 times the smallest side, and you have the height.